So welcome back to the third episode in modular synth design using KiCad, and we're building a buffered multiple. So I think in the last episode we ended up having worked out plenty of things around laying out our PCB based on the schematic that we designed. So in today's episode, what I want to do, firstly, a shout out to Spectral Unit. Thanks for the comment on the first video, actually, where we laid out the schematic. I don't know what I was thinking when I did this. So I have actually built this module, and obviously I was working from a different project. And during the schematic design of the op-amp buffers, I made a fatal error. So thanks for pointing that out. So we'll start off by correcting that error with the buffer circuit. Then we'll relay out the PCB to make sure that it's actually connected after our changes to the schematic. Then we're going to fix the silk screen layout so that we can see all of the components and their designators, reference designators, clearly when we actually hold a physical board in front of us. And then we are going to check that all our traces and things are actually physically valid, so that when we get to manufacturing, we're not going to run into, slicing through a trace accidentally with a hole and things like that. And once we've done all of this, theoretically, our board is ready for manufacture. So we can export gerbers and zip those up and send them to one of the manufacturing companies. I haven't quite gotten a PCB manufacturer at home down just yet. So, all right. So let's get into it. So starting off with those schematic issues, if we remind ourselves, we have these two quad buffers, and each of them is bringing in an input and splitting it out into copies of that input for 3 outputs and an indicator LED. So what I want to do is go into one of these because there's a problem with the buffer circuit. This is, if you look closely, an input signal is going to come in, it's going to bypass the op-amp and go out. Needless to say, also, this is not the way to connect an op-amp. So, yeah, this is not going to give a good desired effect. So instead, what I'm going to do is just remove the ground. So, and remove all of this. The feedback circuit was in the wrong place. So what it should actually be is we should have a feedback circuit or feedback loop between the output of the op-amp and the inverting input of the op-amp. The signal's coming in the non-inverting input. In other words, what this diagram is actually saying is that if we send 1 volt in over here, 1 volt will come out over here. And that's exactly what we want. And the benefit of a buffer is that an op-amp does not pass any current. So the current that's coming in here, when we start processing it down the line, is not going to get impacted. So imagine these were all light bulbs connected to a 9-volt battery or something. The more of them you add, the dimmer they're all going to get, because each of them is sucking current, basically. So the whole point of buffering is to prevent that kind of fade, the effect that we're going to get by supplying fresh current here on the output. All right, so we need to do the same for all the others. Go. In fact, what I could probably do is just duplicate that and pop it on, just make sure that it actually connects to the pins. Duplicate again, Command D, duplicate again, and pop it on there. Okay, so I'm much happier with that. Yes, very good. So I guess, remember we had 2 quad buffers. If we go back to our root page, so we edited this one, but because we've copied this component, it should theoretically, if we go in here, have fixed it on the other one as well. So that's pretty cool. Now, of course, having made this change, we had beautifully laid out our our PCB. And having made this change, now we've actually changed how things are wired up, which means that we've got to make changes to the PCB. So I'm just going to save this, and then I'm going to go to the PCB. And as always, if we want to update the PCB from the schematic, I just click on this. And you can see that it's changed some nets and reconnected some pins, which is exactly what we wanted. So now the problem is we have some things that are connected that shouldn't be, and yeah, so we're going to have to work out what's going on there. So if I maybe just press H to dim things a little bit, and probably I'm just going to look at so you can see here we've got a ground going across where it should be the U2D net. And yeah, so we've got some issues here. So I'm just going to nuke that, and we no longer need the wire. Just checking the other side. Yep. Okay, and U2A, so it feels like that should be connected over here. So let's just refill. Oh, that's really interesting. I need to be showing the rat's nest, and that will help us decipher all of this. Okay, so now we can see that these two need to be connected, and this one is missing a connection, and so on and so forth. So I'm just gonna, again, we've got an input going into the wrong net here. By the way, I can select the whole trace with U and just delete it. The input actually needs to go there, right? So I could press X and connect those two up. Kind of a simple change. We've also got this problem over here with the input. So let's just delete all that stuff. Right, so we've got this input here. Yes, that's right. And we seem to have a hanging input over here. Okay. So we connect those up. Then again, more input problems, input net problems. Just cleaning up all of the issues here. So this one, let's do the easy one first, like so. And then we've got an issue because we need to connect this guy, and it's got to cross. Oopsie. I've got another problem here. I feel like almost like we just want to take all these tracks and wires and just nuke them. And just do this again. Bit of a pain, but welcome to the life of prototyping. Same deal on the side, because we just sort out this power a little bit. All right, so this was going here. Not totally trivial, right? And there, but now we've got this acute angle here, which is not great. I'd rather do something like that. Okay, so we're getting there. 23 unrooted bonus. Okay, so now, theoretically, we should be able to just connect ground up. Minus 12. Refill the copper. Connect that up. Right, so we can see these ones are all part of the same net. So I'm going to start off by doing it all on the side, and no doubt it's going to give us some issues for this, but we need to solve for. So those two nets still need to get connected, but we've still got the input coming in over here, right? So let's take a look at that. Go into the back layer, just undo that. Let's go straight across, and then let's switch layers with a via and go up. Refill. Hey, how was that on the ground? Select that again. Place a via. That's better. That's now on the input. Okay, so we're getting closer. Of course, I could just do this, but I think that's going to cause us difficulties for other things we'll see in a moment. Let's start with that. And let's get these ones in. These ones, if I press the tick key, I can see I have to connect all the way down there. And on the front, yeah, so we're going to have a little bit of fun with this. And that should not be connected to that, surely. Yeah. Right, correct. That should not be connected. So I think what I'm going to do is take this instead. Wow, this input is wrong, like now all over the place. Brilliant. Okay. Okay, so this needs to get there, that needs to get there, that needs to get there. And this is all in fact input, right? Just look, so generally speaking, we don't have a lot, but generally speaking, it looks like I'm using blue as kind of vertical lines. Yeah, and I haven't really gotten that pattern down quite right. Okay. So we've got the input connected. Let's take a look at the furthest one away, because that's going to be the hardest one to get sorted. I'm just going to bring it across, switch to the other side, and of course, super tweaks. And now, problem is that whole copper zone is unfilled. There we go, sorted that out. Perhaps we just move this a little bit to get a bit more copper filled there. And that needs to be connected there. Now we've got this fascinating problem of needing... Why is this violating? That's all input A, that's good. So if, it might have been a routing start point violates the RC. So this one is wanting to come across to there. And we're going to spot the problem now when we switch layers. Please, I want to be a... I can't put a VR because there's a big background on the bottom. Let's just show a little bit more of that so we can see what's going on. Yeah, so that's not great. Things have gotten very messy here. And this may result in... I'm just going to move this horribly out the way just to see if that's what's going on. Okay. So you see we can't get across here, so we're going to have to switch onto the front copper. Oh man, something is not wonders here. Give me a fear. Violates the... Oh, because there's, of course, a red pad on the back. So it looks quite a lot like we might need to relay this out, like, from scratch. So I'm going to do that, and I've actually got a slightly better strategy for now for all of this, because if you think about it, we've got... If I just go back here, we've got 2 units that are, for all intents and purposes, exactly the same. The only difference is this input going there. So it's kind of like this is the first one, and it's going to be shown from the on the panel from input, output, and maybe a little LED at the top, and then the next one will come below it. So maybe it makes sense rather just to lay one of them out, like the first one out, top down, and then the second one out, top down. So yeah, so I'm gonna do that. So the controls are all there, the power's there, but I'm gonna relay out the op amps like completely so that it's almost exactly the same layout for both. That will simplify things. So tracks, pads, vias. Sorry for you. You are the weakest link. Goodbye. All right. So let's get footprints back in. Let's just see a little more of what's going on here. So this, I'm going to move. I'm going to find a way. Is there a way to get it up here, perhaps on the back? Why do I still have tracks when I thought I deleted them all? Still tons of them. Right. Okay, so new plan. I'm going to move this so that it's at the top right of the board, and I'm going to move this down. Hey, move. Why is it? The behavior is not how it used to be. I'm just going to, you see, so I can get it to about there at best. And then, how far can I move this one down without it colliding with the power stuff? Probably about there. So let's see. If I then distribute those vertically by centers. Okay, other one. Distribute vertically by centers. And just look at that quickly in this view. Oof. It looks like one big component. So that's not they're overlapping physically. Also, should have moved these together with those. I'm just gonna kind of do that. No, it's on the board. That's just. And this one, if we look at it now, oh wait, I first want to distribute these. They seem to have gone out of line to horizontal center and distribute vertically. They are still, I think, overlapping. It would seem so. Okay, let's get these. That's okay. Let's just see how far we need to go. Line distribute, vertical centers. Okay, those are definitely apart. I can see here. So there's enough of a gap between them that we can physically place them like that. So they're closer together than they were before, but that's fine. Totes fine. The only problem now is it's crashing into that, but that's fine. We can fix that. And on the top, just want to check what's the problem. It's not that, so we could go as close as that if we wanted. So let's just do that, just to get them a little further apart. And then we can fix the other issues. That might be a bit close for comfort. Let's just do that. Okay. Perfect. It's only clashing because the courtyards, if we look at the front courtyards, you can see that they're overlapping here. But I'm not worried about that because we can physically fit them as we need them there. Okay. So then, of course, what I've got to do is grab all of these guys, and we want to at least just align them So let me align that to the bottom and align that to the top. And then distribute these vertically. Okay, so now at least it's the same. I'm just going to move these out the way for now. In fact, what I could do is select all of them and move them in one fell swoop. And by the way, I'm holding shift, otherwise it really irritates me that I can't place it where I want it. Roughly there. Okay. And then I'm going to bring these totally down here and just align them to the center of that. Line to horizontal center, which it's done. And then, of course, all of these need to be moved again because I accidentally included those. And then we can move these back on. Oh, I left off the LED. Fine. We'll do that as well. In fact, I might as well just align it right now. Okay, double check. Is that aligned to this? Yes. Then align that LED to that LED horizontal center. And then move this back up here. And sadly, I've got to do all this again. But the point is, I want that and that to be aligned vertically. Nice. That aligned to the top again. That aligned to the bottom again. And then distribute vertically by centers. Okay, so now that whole block is the same. And then let's see how it fits on here. I'm actually just going to move all this stuff out the way. At least the stuff that relates. That's the LED. That's the power. That's the power. And then these two are actually belong to, no, not both of those. This one belongs to this guy, that op-amp. It's the bypass cap. And this is the other bypass cap. Right, so now we've got a whole lot more space there. Let's just get these controls in place. I have to line them vertically again, on the horizontal rather, but I just want to get them to maximize usage on this board. Something like that. Align horizontal center. Align horizontal center. Right. Okay, so now probably move this out of the, well, do I even need to? But I can if I want. Just get these guys a little bit out of the way. Because we need to make space for an op amp to go, this op amp, right? So in fact, I'm going to move this out of the situation completely. Could even do the same with this. Would it fit on the other side? It would fit there if I move these a little bit. It's so close. I mean, I could even put it like that, but I don't like doing that. Okay, let's just say it's like that. And then this is the other. That might even work on the side. No, definitely not. But it would work over there. Neato. Let's have a look and see what that looks like. So we've got our power and we're making this big open space here on, actually on both sides of the board, potentially. And in fact, this whole thing could move down if need be. There's a bit like down in this direction because it's not quite centered anymore, right? So press D and just move this somewhat. It's all still good. We can move these. And we could even do the same as what we did on this side. Put them more like this. I don't know that we're gonna, feels like that's still not quite centered there. Get that as far down as possible. Get this and see if we flip this, can it get to where we want it? Not even close. Brilliant. But of course, there's plenty of space for this now. This is for this guy here. We can flip this onto the back of the board, onto the back of the board, onto the back of the board, just to get all that stuff separated from the components. So we've got, now we've got an op amp for the quad buffer 1 for all of this stuff, and an op amp for the quad buffer 2 for all of that stuff. That's the bypass cap for this. So if I put this on the back, which I can do, there it is. Just move it. Jeez, I really don't like this new snapping. Maybe it's useful for somebody, but I don't like it just yet. Where am I? Let's go on to the front. Yeah, it kind of sucks. I'd rather have it all on the, like all the power on the one side. So what's the issue here? It's because these guys are too fat to fit exactly one on either side. So I could move that like so. I could bring this down. That's almost exactly center. In fact, I could center it precisely between those by distributing it vertically. Okay, so now what I do on the one side, I should theoretically be able to do on the other. And I'm just going to move that out the way. Now, which side do we? I think we want this all on the front. So flip it that way. Plus 12 really needs to be connected with this one. And with this one to ground. Those are still too close. So maybe I'll have to stick with that being there. Yeah, that's good enough. And then if I do something, oh, what's this guy? I think that's the LED resistor. Move that out the way for the moment. Go back to the front. Okay, so we've got this kind of a pattern on both sides. This one is the guy that we had like this. And then these are a little more like this. Okay, so now it's looking a bit more symmetrical. So we've got like our ferrite bead, our diode going into our power caps. So this looks like a reasonable power circuit. Just see if it looks a little, that looks much better on the front. Right. And then we've got the space on the back for that. So and when I say we got that space on the back, it's not really enough. So probably this guy wants to be on the front. At the top, that one's on the back. So I don't like that. I want it all the same. So can this move? That could move. There's a little bit of a space there. It's better. Very nice. Okay. Now it's to just check which way around we want to orientate. Which way around we want to orientate that op amp. So that's going to this side of the op amp. That's going there. And that obviously is going to the top. Brilliant. Okay, so that's fine. So the trickiest one to connect is going to be that one. So we probably want to start with that one when we're making those connections. And then plus 12 bypass cap. Probably wants to be there-ish, close to the plus 12 pin. Minus 12 bypass cap. Probably wants to be there-ish, close to that. Minus 12 volt pin. And this is the resistor for this LED. I'm going to probably put it out this way. What if we put it on the front? Okay, well, I'm just going to keep it on the back and keep it there-ish. Get that spoke back in if we can. There we go. All right, because it's got to kind of go around up to here. Now, the alternative is I could flip this. Maybe it's not a bad idea, although then the power's got to get across. So trade-offs for everything, like if we had to put this like that, but even then it's, oh, no. Okay, let's try like that. And this one is the resistor for the LED. Yes, I did finish that sentence. And then we've got bypass caps for this slot. So these are going to have to go on the front. Let's just see a bit more of what we're doing here. So at the very least, so I could go like that and like this. I sense collisions in the future, or even what I could do is put it like right on there and connect it with a wire. That one I can't because we've got a jack in the way over here. Could even go like that. Like that or something. Okay, so it feels like we've kind of got everything back on the board. Bonus. And at least we've got the concerns of Opamp, of Mult 1 and Mult 2 kind of together, their components together. All right, so then it's a matter of trying to wire this stuff up. Just want to check these guys. Yeah, that's okay. We'll see how that works. So of course, back to what we want to do, I want to get rid of looking at anything other than where power needs to be connected. And for some reason, could be for reasons of that, I'm not seeing the unrouted powers. It's just, click twice, who knows. Okay, so let's see. Let's just do all the easy ones first. I wonder if this can move just a little bit, because those pads looked a bit close together. Just check that we don't have the same issue at the top. Yeah, we do. It's really interesting. Oh, there we go. Just go until we hit it and bounce back one. Let's get some tracks in our selection. Okay, so we've got somewhat better looking circuit there. We need to connect 12 volts. I'm going to use a wire here. Well, let's do it without first, and then you'll see probably what's going to go wrong. No, that's all good. I was thinking this island might become an island of zone 4, but it's not. Okay. Okay, then all those grounds that are on the top copper, we can just fix with like a VIA. And that's now connected to ground. Same dealio here. Same dealio here. Same dealio here. Okay, so let's look at, so plus 12 volts is the whole zone. So that's obviously on the back copper, so it's not connected to the front copper zone. And same deal with that. Okay, so we can connect both of those up and connect this that net to the front copper with a via. That's connected. Then those two. Okay, so minus 12 volts. We don't have a plane for. But let's finish 12 volts first. Plus 12 volts. And it's over here. Just going to drop the via off there and then come back onto that pad. Very nice. So I think plus 12 volts is sorted. Nice and easy. Minus 12 volts, let's go with that and see what needs to get connected. So we need connection between those and that. Nice and far away now. So let's see. So I'm going to bring this up, drop a via, switch to the other side. Drop another via, switch to the bottom copper again, and drop another via, switch to the although, yeah, no, that's probably for the best. So now we've got, but we don't have this one connected. Yeah, that's a nice fat connection. Okay. Anyone on minus 12 volts? Calling all minus 12 volt connections. So another thing that we could do here is come up here, drop a via to get around all this stuff, and connect in there. So now we've got all 12 volt connected. I mean, I could, of course, do that instead. Let's see if it makes it tricky to connect these guys up. Actually, it shouldn't, because these are below here. So that might be a neater pattern for minus 12 volts. And maybe even get rid of this whole U over here and just, oops, deleted the jack. Okay, just let go of footprints, please, and select wires. Refill, and then theoretically that could also connect. Right, so that might be neater. Looking good. Okay, then let's just take a look at ground. So who is not connected to ground? So we want to see on the top layer. They're not connected. So could go like this and like that. And maybe not that one, but this one. Maybe just push that to the edge. Oof, and I don't like that little... I mean, technically, I don't normally do this, but we could just get rid of all of that and just connect those two pads across layers directly with a wire. Probably not best practice, but it'll do in a pinch. Okay. It's just that we want the cap that's on the front there. This guy we want connected as close as possible to its power pin over here. So probably better to do that than have traces going backwards and forwards. All right. Who said PCB design was easy? Okay. So we're getting there. I think we've got all the power sorted out. So let's take a look at the other nets. And this is probably where I find, oh darn it, should have, oh no, it's okay. So it's just that one that crosses over, but that's fine. All right. So let's connect up all of these other bits and bobs. This LED is going to be a bit of a pain because it's got to cross all of this stuff to get there. But let's do it. LED. Let's just put it in, even though I know this is probably going to cause pain. Like that, for example. Okay. And because we've got these other signals, this one, thankfully, is going right there. So I'm going to connectorize that up. Then this one is going to have to via out. Switch layers and via back in like so. Okay, so now those ones are all connected. And we've got it connected up to the other side as well. So we could do this like so. And now it's just those two that need to be connected. And I think that is okay. apart from let's just do it like this. Okay, easy. Then all of those are neatly connected. Well, they're connected. Those two need to be connected. Those two. Let's do this one first. Okay. And this one is going there. So we're probably going to want probably the simplest way would be to pop it onto the front copper, bring it to the other side here, and then just boom. Right. Something like that. And then this one needs to connect up. So we'll do something similar. This time let's just see if it's gonna fit through here. Look at that. It's like magic. And then we can pop onto the front layer again. And to cross this line here. Flip back. And boom. And then again, I've got an acute angle there, which I'm not so happy with. Okay. And then we've got that normalized input from input A down to the switch of the second mult. So that's going to be a nice long trace. So I'll save that. I'll save that challenge for later. And in the meantime, let's just whoopsie. Let's just get all of these things wired up. But I think other than that, this whole top section, other than this guy, everything up there is wired. Beautiful. Okay, so now we do a similar exercise on this side. We've already got power. We just need to start connecting up all of these. Those are outputs to the inverting input on each of the 4 op amps. Okay, I'm going to do this knowing that it's going to give us some hassles probably. Look at that. We just got all this beautiful free space over here. So I think for this, I'm going to try use some of that space. Well, let's just do that. We'll solve the next problem when it comes up. Okay, and then so that is second to last. That's the tricky one. And I mean, I might as well just move these a little bit. Now that's really interesting. So this, that's a resistor, of course, resistor to ground. That's the input impedance, and these are the output impedance resistors. So, okay. Ugh, I don't like that. Better. Save regularly. That wants to go there. That one's going all the way across. Let's just see if we can get it there by flipping onto the front. Then we'll need to via boom. Okay. Let's see how we can get there. That would work. Okay, so that was the hard one. And let's try a similar pattern, and I guess now is where we're going to run into some hassles because we can't get two through there. So we could either come up on the other side of this line and push this a bit further. Let's try this approach. Literally just go there and then come up here, and then we're going to have to go across again. Overshot. Ooh, I'm starting to see a potential problem here, because actually what we're doing is we're starting to block off the whole of this copper zone from its section above here, but let's see how we go. Yeah, exactly what I thought was going to happen. Okay, so there's 12 volts. I might just do that to kind of okay. For a start, so we're making a bigger channel. This is the only thing connecting plus 12 volts for that zone. So we might be able to find other ways to help out. We can't move around because that line is kind of in our way. And of course that's gonna block that out, so marginally better. And now this section is islandish. Yeah, getting there. Save. Right, then we've got this story over here as well. That could be solved like that. Or like that. Save. 3 unrooted, we're almost there. Amaze balls. Okay. Let's start with that one. Then with that one. And then with that one. Actually, I could come around this way. I mean, it could just go boom. Let's see. Okay, and then this one. simplest way is just direct like that. But as you can see, we're blocking off some zone here. Just move that ever so slightly. Okay. That's a problem. That will fall there. Keep going, then it cuts there. Yeah, I don't like that. Not the end of the world, I guess. Just looks messy, that's all. Right. Let me try a different approach here. And the different approach would be to say, let's get that across. Let's switch to the front. Let's go up. And let's connect. Okay, so we've got that problem. Of course, if this LED was rotated around, we'd have more space to bring things up through here. And this is another path that's chopping off. So we could do this and just double via that. Oh, right, I'm not showing the power. So I could go like this. That's not exactly what I wanted. That, swap over via up. So that opens up there a bit better. I guess the alternative here is to not do that, but rather that opens up the channel, and then we can switch over to that layer. Yeah, that's a bit better. Okay, then we've got two left. No, we've got three. Oh, because of this. So then this one, yeah, not much point in bringing it up there. Might as well bring it across, flip layers again there. Okay. Good enough. So now it's just that last one. That wants to connect to that. So let's bring it down. I wonder if we don't want to bring it down the outside. Bring it here. Flip to the front. Bring it down some more on the back. Yeah, that's the cheap and nasty. Unless we just go all the way around here. Does feel like it makes it a little bit long, but it's really not that long. Boom. Not unrooted. Right. So with any luck, we're now back to a little bit of a better layout with those op amps connected correctly. And yeah, back to kind of where we were. And it was only an hour and a half. So yeah, amaze balls. So that was the fix layout, sorting out the op amps and actually getting them together with the part of the circuit they belong to. Very nice.